All right, so yeah, we're going to have roots between -1 and 0 right in here because we switched from negative on this side to positive. Where else will we have roots? I can see your thought for why between 2 and 3, but I would word it slightly different. Because where is the root that is going to show up with that 3, 0, -1? We will have one between 3 and 4. What's going on with this other one? Why didn't I put a line between 2 and 3? Because where is the root that's here? Because remember, our roots are solutions, roots, x-intercepts, or zeros. It's right on 2. So this is a root. We don't know the exact value here. It's between these two. It's between these two. So when we have a 0, it still counts as a solution. And we'll see that when we get to our graphing stuff, which mine isn't numbered, but I know the one on the Bauer paper is. So we've got our -1, -9. So we're going to have a thing way down here. 0, 2, 1, 3, 2, 0, 3, -1, and 4, 6. So again, we've got kind of this chaos dot situation going on. We're going to start either from the left or from the right. I tend to go left to right just because that's the way we tend to write stuff, but there is not a, I mean, there are wrong ways to do it, but it's just personal preference. So I would probably connect them like this. And we can see here our little estimates were right on. We have a root between 0 and -1. We have a root at 2, rather, and we have a root between 3 and 4. Our roots are solutions, our zeros are x-intercept. That is when it's crossing that x-axis right there. What is the domain of this f of x function? Remember our domain, that's our how far left, how far right. So we can go from -infinity to positive infinity. What's our range on this one? Same thing. It's going, looking top to bottom, how far we can go, and this goes from -infinity to positive infinity. And that will always be the domain and range of odd degreed functions because they have that opposite end behavior. Since they go in opposite directions, it's always going to be -infinity to positive infinity. Okie dokie. All right. Questions on this one? All right. So again, this is week 2. Please also make sure you put your name on your bell work page. I've already had two things turned in with no name. For the 3 things that have been turned in, I've had 2 pages with no name on them. So make sure you put your name on stuff. I'm good, but unfortunately, psychic is not one of the skills I possess at this time. All right. At this time, I retain hopeful that someday I shall get my psychic powers. But it hasn't happened yet. So, I need you to help me out. Unfortunately, it's not one of those things that comes with practice. All right, so we are going to look a little bit more using our location principle, looking at our extrema and what that means. looking at some things kind of in context-ish, which means there's going to be 2 problems to do today. But that does mean they are slightly wordy. So, there is one of such problems. I'm going to give you guys graphs. I did not print the words. The words are not super duper important. What we're mostly looking for is the graph, and we're going to describe a few things about it. But I gave you guys, I printed out the graphs so you can have them the same style of graphs as long as the back side of the card. Thank you. It was always some of their survey back. It has thus far not ever time I've done the start on the nail. Starting the video. So, here we go. I'm so good at.
Oh, no, never mind.
Okay. I was going to say, notice how I didn't question that even one bit. I don't know why, but this row, every class, no matter what period it is, no matter what subject it is, I can never get the center row with the right number of things. I don't know why. My brain just blocks out. It's either one too many or one too few. More often than not, it's too few. But I have this binder. That's what I was going to grab. My brain is not ready.
The ADHD medicine hasn't kicked in yet, you know?
It's on the process. But also, I was like, I just did not want to wake up this morning. So my husband was like, don't you normally leave around right now? I'm like, oh, shoot. Yeah, I kind of do. So it was one of those mad dash mornings. So I'm still working on getting the beginning of the coffee. I'm only this far in. We're getting there. All right. So we've got here that you are in business. Woohoo! We love a business queen. And the profit in your company is based on the price of your product. Sales of your product are represented by this equation. So when we're looking at those graphs I just gave you, why did I only give you a portion of a graph? Why didn't I give you a graph that had the whole, like this shape thing?
Because they don't go into.
Because we're not going to go into the negatives. We're based off the price of our product. That means the thing we're controlling, the thing we're changing, the X is the price. Am I going to price my product at -$1 or -$2?
Free.
That is paying people to take it. That is not going to make me money. That is, here, please take my pizza and enjoy $5. No, that is a bad idea for business. So that's why we don't go negative on our x-axis. A lot of times we're in these kind of real world situations. If we go to the left, it would be either negative, like charging somebody negative, or negative time. So same thing with down here, it would be our profit being negative, which while technically is a thing that we could do, is bad. Business-wise, that is a bad idea. So if we're looking at this kind of thing and we're trying to figure out how to graph and figure out what's going on with our profit for our company, and we want to make a table to graph it, what values should we pick to do like we did in the bell work? Because we're going to fill in a table, but I didn't give you one this time. 0 is a good place to start because I'm definitely not charging you $. We don't need to do the -2, -1 because I'm not charging you $. To take my product. Thank y'all. So starting at 0, and then we can go bigger. Like maybe it charges $1. Maybe we charge $2. And we can try a few of these to see what's going on. So we're going to try and figure out what's going on as our price changes, because price is going to be our X's and our profit's up here. So we will have to label our own scales. I'm going to count by ones here. That will usually work for us. So let's substitute those values in and see what we get for our Y values looking at our profit equation. We're going to start at 0. We're going to look at 1, 2, 3, and 4 and see what we're getting. So if we put in a 0 for X and substitute that in up here, what are we going to get?
4.
4. 0 is probably one of the easiest ones to do because it's 0 plus 0 plus 4. How about for 1?
5.
Mm-hmm. How about for 2?
4.
Mm-hmm. Make sure you guys know how we're getting these values. If you don't know how we're getting it, check in. How about for 3?
I got negative.
I also got negative 5. It's okay. Again, we said that's when our profit is bad. Business bad. We don't want that, but it can happen. What if I set my product's price at $4? Will I make money?
No.
No, very, very much. No, negative $28,000. So we're going to sketch this up, and that's going to let us see some things about our business and what we need to do to price our product. So we have 4, 5, 4, and then a bunch of negative stuff. So I'm just going to count by ones over here. 1, 2, that is the wrong pen. 1, 2, 3, 4, and 5. Just to not make things too complicated. So we're going to have our 0, 4. Got a point here. Burp, burp. Our 1, 5. 2, 4. And then 3 is down negative 5, way down yonder. And then 4 is even further.
So we just put the 1 arrow.
So you're gonna have the 1 arrow.
It's taking.
Oh, wow, I'm really bad at getting those in good spots. No, I'm not too bad. Okay. So, what should we price our product at if we want to get the most profit of anything that we had in our options here? Where should we look for our highest profit? Yeah, this guy up here, right? What is that kind of point called? It's an extrema. It's a maximum. So this is one of those extrema points. This would be if I set my price at $1, that's when we had our most profit. We're going to profit about $5,000. If I set my product to be $4, are we making a profit?
No.
No. Everyone goes, excuse me, no thank you, I will not pay that much. Sorry about ya. So if we want the most amount of profit, we're looking for one of those extrema. That's what those points are looking for. If we're looking for when will my profit be 0? When is my break-even point, the absolute highest we can go? Where is my profit 0?
Between 2 and 3.
Between 2 and 3. So somewhere in here, we'd have to do a little bit more research to find that. But again, that's where we're switching from positive to negative. So our roots, our solutions, our zeros show us when our y is 0. So this would be our max profit. And then this guy is profit is 0. So again, this is also our extrema. And this is our root, solution, 0, x-intercept. So those same concepts that we have been talking about are one of those things that get used in business analysis. Ta-da! When does this get used? Try to figure out the price of your profit based off science that has been done off of your products. Snap, relevance. What? Who's she? We don't know her. Okay. Double checking that we've gotten all the things that we need to on that part. Yes. Cool, cool. How did I know, aside from the fact that I've done this before, that I did not need to keep going to see if this arrow will come up. How can I tell for sure that this right-hand arrow is going to go down? By looking at this equation. Yes. So our leading coefficient is negative, which means my right arrow is going to point down. My degree is also odd, so we know that it would point in opposite directions. So if I had a left arrow and I kept charging people negative, things would go all kinds of weird. But because I have that negative leading coefficient, I know that right arrow is going down. So when I see it going swoop down, that's probably where the end is. And we don't got to keep looking. So we're going to do the same kind of vibe for another problem, and then we'll have time to work on the homework. We'd have that. All right. So now we're going to do a different one. We're going to do the height of a plant in some new special sciencey fertilized growth soil. Gets this equation. And x is the number of weeks since it's been planted. So again, we don't have a negative on our x-axis because I cannot plant a seed and then go backwards in time. I'd love to, like, if we could do the backwards in time thing, that'd be great.
We haven't.
Change some choices. We have not yet invented the time machine. If somebody does so, please let me know. I would love that. However, it is not a thing yet, so we cannot go backwards in time. We will not have negative time. So we're going to look at this plant, the vague plant. Maybe it's tomatoes. Maybe it's flowers. Maybe it's a tree. But we're going to look at that, and we're going to try and figure out what is going on with this plant looking at this new potting soil. So we're going to pick some x's. We're going to find some y's. What kind of x's should we do for our number of weeks? What should we pick? 0. Good idea to know how big it is when we put it in the ground.
1, 2, 3, 4.
Yeah, keep going till we figure out what's going to happen. What should happen at the on the far right side? What's my right-hand arrow going to do? Where's it going to go?
Up.
It's going to go up. My degree, again, is 3, so we're still on an odd function, but we're positive on this side, so we know that right-hand arrow is going to go up. So that end behavior stuff still gets involved here. So my right-hand arrow is going to go up. So once we start getting some goofy numbers, we can figure out what's happening here. So we're going to put our weeks. There's our x's. We've got our 0, 1, 2. So let's see what's going to happen there. I'll give you guys a couple of minutes to substitute some of those numbers in. Type those in, practice that. Make sure we get the same thing. Run through that. All right, so substituting these values in, what do we get for 0? So we didn't plant a seed, we planted a little seedling, a little baby plant. So we're going to start with a 2. What do we get next? For 1. 1. So we kind of lost a little bit there. Got a little scared. Then what's next? For 2. 6. So we go. Whoop. And then for 3.
29.
29. We start experiencing some rapid growth. And for 4.
82.
Don't feed the plants. get little Shop of Horror vibes on that now, because that is growing really, really fast. If we have gone from 2 to 82 in the span of 4 weeks, that is a very, very fast growing plant. Thank you, Audrey, too. Little Shop of Horrors, come on. Classic movie musical, Broadway musical, stage show. It's amazing. It's fantastic and hilarious. Genuinely hilarious. Okay. So that's what this one's going to kind of look like. So what does this tell us is happening to our plant? It does grow rapidly. But what happens in that first week? It goes, So it gets a little bit of this like shock kind of thing. So it shrinks a little bit. And then it just goes whoom and whoosh way up. So what kind of extrema do we have here? We have a minimum. So we see that it's going to go down a little bit lower. We have a minimum here. Where do we have roots, solutions, zeros? Nowhere. We don't have any here without going backwards in time. Because if we get it down to a height of 0, we've had to go back over here somewhere because this is an odd function, so it will come down somewhere. That just means this plant never goes all the way down to the ground. Because that would be bad anyway, unless you have a duck that comes and eats it.
Or unless it dies.
Or unless it dies. So this plant never actually dies in this soil. So we don't have any zeros, and that's an okay answer. Like, if it doesn't exist, it doesn't exist. It's not there. So we have no zeros. This plant never dies all the way down to the ground, but we have a minimum near x equals 1. Okay? So just because it's a story problem doesn't mean it's significantly more complicated. We just tend to see the little paragraph, we get a little scared, and then we say, no, thank you. And turn the page back over. They're not harder. They're the same vibe. Okay? So it's very, very similar to what we did yesterday, Friday. Last time. Words are fun. All right. So you guys get the rest of the time to finish up 4-2. Technically, 4-2 is due tomorrow. We're also going to do a little skills check tomorrow. So I'm telling you so it's not a surprise. Y'all are going to come and go, what? We'll also go through the homeworks together. So we'll look at 4-1. We'll look at 4-2. Okay? Just because I don't want to give you a skills check when you haven't had a chance to get feedback. All right, so I've got all the 4-1s that got turned in on Friday graded. They're all up in Canvas, which should have gone over to Skyward. I haven't gotten a chance to double check that process functioned correctly, but I will double check it. So you guys get the rest of this time where you can work on stuff, ask questions, finish up 4-2. The backside has story problems like this, but it's not any different than what we did last week. Okay, so 4-2, if you need another copy of it, I have them up here. I'm going to put my stuff down so I can have hands again. If you ever need another copy of homework, they're in this pocket right here, and they're just sorted by file. So homework 2 is in this front one, homework 1 is in the back one. We was missing that. If you ever need an extra copy of the bell work pages, I put them up here when we're done picking them up. So, okay. All right, so work on stuff. Let me know if you got questions, all that jazz. Pretty chill. We got more than 10 minutes until we get to announcements. So work on stuff, ask questions, all that jazz. Yeah.